So here we've got a slightly more involved example when we're not given an equation. So Emily sells cooking accessories, okay? Now her company pays her $300 per week. So that's, again, when she walks in the door, she gets $300 per week, plus a commission of 4% on her weekly sales. So obviously when she sells a really fancy spoon, she doesn't get all of the money that the spoon costs. That goes to the company, and then they pay her a small portion of the sales that she makes. So we're saying maybe in her first week, she's just starting off, she sells $3,200 worth of products. Okay, so how much would she actually get paid again? This is nowhere near what she gets paid, that's just how much she sells. The pay is very different. And then we're asked to complete a table of values going up by increments of $10,000. Using kind of what we discover in this process, we'll write an equation, interpret the equation, and then plot a line. So the first part, in her first week, she sells $3,200. How much would she get paid? Well, we know that she gets paid a flat amount. Okay, so that's when she walks in the door, she gets that money, plus the amount that comes from the commission. So a portion of this $3,200 rather. Okay. So we know the flat amount, well, that's the $300. That's what she gets as soon as she walks in the door. Now the amount that comes from commissions, well, she gets 4% of that amount. So think back to good old percentages. So 4% of 32,000, well, 4%, we write that as 4 over 100 times 3,200. So plus, we're going to write that out exactly. 4 over 100 plus 3,200. Again, at this point, you could just chuck that in the calculator and be done with it. But just kind of being a little more complete there, we can write that as 300 plus 0.04 plus 3,200. Let me just quickly fix that. Okay, so we could write that 4 over 100 as the decimal. Okay, now again, multiplying that out, I've done it in 2 steps. Of course, you don't have to, you can just do it all in one. So we get that that's 300 plus 128, or $428. So our concluding statement, she gets $428, which isn't bad, when she makes $3,200 in sales. So again, this is her first week. Maybe she's not selling as much as she could. So then we go on to setting up a table of values. So again, the first one, that's kind of the freebie. If she doesn't make any sales at all she gets is that $300. Now for the 10,000, we have a little bit more work to do. Now, so we want this $10,000, so she makes $10,000 of sales, how much does she actually get paid? So we want to come back to this principle that the pay comes from 2 components. There's the flat amount that she gets regardless of how much she sells, plus there's the amount that comes from the commission. So again, in this case, the flat amount is the $3,000. The amount from commission, well, we kind of went over this in part A, 4%, that's 4 over 100 times whatever amount. In this case, the amount is $10,000. So I've converted to decimal. Again, you don't need to do that. You can put it all in the calculator straight away. But going through the calculation, I get that she's going to make $700 if she sells $10,000 worth of goods, worth of cooking accessories. Now the next month for $20,000, and we've seen this calculation a couple of times now, so it's going to be 4 over 100 times 20,000. That's going to be how much she gets from the commission, 4% of that amount, plus the flat, working that out to get 1,100, and then finally for the $30,000, same calculation, but just plugging in 30,000 to get 1,500. Okay, so it's increasing by $400 every time we go up by $10,000. Okay, so we're not going up by 1 unit, we're not going up by $1. I've gone up by 10,000, so she's increasing by $400. All right, now we want to actually finalize that equation. So we've essentially been using it, we just haven't put variables in it. So again, we come back to this principle, total flat amount plus the amount from commission. Well, the flat amount, that's the 300. We've used that a few times now. And the amount from commission, well, that's 4% of whatever the amount from the commission is. It might be 10,000, 20,000, 30,000, whatever it was from the previous examples. Okay? But in this case, we don't actually know how much. It could be any amount, so we're just going to call that amount from commission. Now we want to replace those with variables. So P is her weekly pay, so that's this here we want to replace with P. And weekly sales, we're going to use the letter W. Again, the reason I don't like using S is because it can look like a 5 if your writing's a little bit messy. So just do be careful when you're using variables in that way. So P is equal to 300 plus 0.04W. Because we typically like MX plus C, I've reordered those to 0.04W plus 300. But again, it's the same regardless of how you're working through it. So that's our equation. Now let's go through and interpret it. So we want to interpret the gradient and the y-intercept. So same deal, we need to identify from our equation which one of these two numbers is the gradient, which one's the y-intercept. Once we've decided that, then we can go ahead and interpret. Gradient, that's my coefficient, that's the one with the letter. So that's my 0.04. Okay. In this case, well, we already had the scenario to start with. Well, it represents the percent of the pay on commission. Okay, so it's a little bit different than the increase in blah when blah goes up by 1 unit. Well, we know that came from the fact that Emily gets paid 4% commission. But if you want to think of it as an increase of what in terms of the other, so she gets paid an extra $4 for every $100 of sales, because 4% is 0.04 is 4 over 100. So for every increase in sales by $100, she gets paid an extra $4. So a few different ways to kind of word your answer there, but really making it clear that it's to do with the amount she gets paid compared to her sales. So that leaves the 300 to be my y-intercept. Well, that represents her flat rate. Oops, that should be Emily, sorry. So Emily gets paid a flat rate of $300 per week, regardless of how much her sales are. So even if she doesn't sell anything, she still gets $300 for working for the company. So we've started with this scenario, we've got our equation, we've interpreted our equation, now let's graph it. Okay, so use your equation to plot a linear graph representing the scenario. So here, because often kind of from the examples, we recognize the sales could go quite high. I've gone up by 5 thousandths because the table of values kind of hinted that the sales could be that high. I've put a not so great break in my graph. Started it at 200 and then going up by 200s, but a tick in the middle. So really it's going up by hundreds, but it's not quite as messy. That's a pretty good sale based on what we've seen. So we could just plot the table of values, but we do also know what our equation is. So 0.4W plus 300. So that means that's my y-intercept. So that's going to go right on there at 300. Okay. So that's going to be where our y-intercept goes. And then once we've got our y-intercept on the graph, there's a few different ways we can kind of think about the gradient. One is as the decimal. We could use the table of values just to plot our points and join with a line. Alternatively, if we think about it in terms of fractions, well, that's 4 over 100. Or you can think of that furthermore as 400 over 10,000. So for every 10,000 I go over, I go up 400. So if I go over 10,000, I'm going to go up by 400. Over 10,000, up 400, and so forth until I can plot a line. So if you're given a scale, we're thinking about it as a decimal isn't handy, we can think of it as something over 100 just by doing, this is 400ths. So I can write that as 400ths, and then I can bump up my fraction dependent on my scale. So could use the table of values we had from the earlier question, or we can go ahead and plot points using over 10,000 up 400 based on working with some fractions. Okay, so that's a little bit of a different scenario there.